Hello everyone, welcome to my video. If you have been following my previous video, you know that I am doing course on UPSC previous year's question paper. So in this video, I will discuss Civil Service Mains Examination 2018 Physics Paper 1 question paper. So one by one discuss. So you can read this question paper specific instruction. And section A is here. First, if a particle of mass m is in a central force field F r cap, then so that its path must be a plane curve where r cap is a unit vector in the direction of position vector r. And question number B is here. You can see this x, y, z, 3 axis space. A black body of mass m having negligible dimension is sliding freely in x direction with velocity v is equal to vi cap as so in the diagram. What is its angular momentum L0 about origin O and its angular momentum vector LA about the point A on y-axis. You can see this. This is data according to question. So next question you see. Question number C is here. When the two waves of nearly equal frequency interference, then so that the number of bits produced per second is equal to differences of their frequencies. Question number D is here. A currently carrying circular wire loops of radius 1.0 cm has a magnetic moment and 2.0 meter joule temperature. So time. Determine the magnetic field at an axial distance of 3.0 cm from the center of the loops. Question number D complete. So question number E is here. A plane transmission grating has 300 lines in all having widths of 3 mm. What would be the angular separation in the first order spectrum of the two sodium lines of wavelength 5890 angstrom and 5896 angstrom? Can they be seen distinctly? Question number 2a. Use Gauss theorem to calculate the gravitational potential due to a solid sphere at a point outside the sphere. Calculate the amount of work required to send a body of mass m from the Earth's surface to v a height r2 where r is the radius of the Earth. And question number B is here. You can see this. This is a rod of length L has non-uniform linear masses density mass per unit length lambda, which vary as lambda equals to lambda naught SL, where lambda 0 is a constant and S is the distance from the end market O. As so in the figure, find the center of the mass of the rod. So you can see this Z, Y and X. This is diagram. And question number C is here. Two capillary tube of the length 2L and L with the internal radii R and 2R respectively are connected in series. Water flow through them in streamlines if the pressure difference across the first capillary is B, and find the pressure difference across the second ones. And question number D is here. A water drop of radius is 0.04 meter is falling through the air. If the coefficient of viscosity for the air is 1.8 into 10 to the power minus 4, pose and find its terminal velocity. If 100 drops course, what will be the new terminal velocities? And question number 3, this is theoretical parts. Explain the principle and working of helium neon laser. What is the role of helium gas? What it is necessary to use narrow tube? How many longitudinal modes can be excited for a helium neon laser in a cavity of length 13 cm and having half width of gain profile of laser material 2 into 10 to the power minus 3 nanometer. The emission wavelength is 6328 angstrom. So this is optics related parts. And question number B is here. Distinguish between positive and negative crystal in the term of double refraction. How much are their crystals used to make a quarter wave plates? Explain how the quarter wave plate is used to producing ellipticals and circularly polarized lights. And question number C is here. Describe how Michelson interferometers can be used to determine refractive index of a gas. In a Michelson interferometer experiment, a tube of length 20 cm, 25 cm, containing a gas of reference index mu is introduced between mu's refractive index is introduced between the upper mirror and the beam's splitters 115 fringe cross the center of the field of view. When the wavelength of the light is used is 5819 angstrom, find the value of mu. And question number 4 is here. You see, a rod of the length L0 is kept at rest in XY planes of its rest frame, making an angle theta with x-axis width in the length and orientations of the rod in laboratory frames x, y, in which the rod moves to the right with velocity v. So you can see this graph. And question number B is here. Discuss the intensity distribution of a diffraction pattern due to a single slit. Obtain the condition for maximum and minimum of the intensity distribution so that the intensity of the first maximum is about 4.95% of that of the principal maxima. And question number C is, what do you mean by a spherical abbreviations of a lens so that if two plane convex lenses are kept at a distance equals to difference of their focal length, the sphere abbreviations would be minimum. And section B is here. A 12.0 volt battery is connected at t is equal to 0 to a series combinations of a resistor R is equal to 10.0 ohm and an indicator L is equal to 5.0 H. At what rate is energy being stored in the inductor when the current in the circuit is 0.4 ampere. A. Question number 2. So B. Two solenoids have 500 and 800 turns of the wires and are placed coaxially close to each other. A current of 5.0 A in the first solenoid produces an average flux of 200 microweber through its each turn and a flux of 100 microwevers through each turn. So second solenoid, find the self-inductance of the first solenoid and the mutual induction of the solenoids. Question says here, a star is receding with the speed of 300 km per second and emitting spectral lines of hydrogen atoms of wavelength of 656.1 nanometers. What would be the wavelength observed by an observer on the Earth? Question number C. Question number D is here. 1 mole gas of A obey the following equation of a start. P plus 1A A upon B square, P minus B is equal to RT, where B is the molar volumes and A, B are constant, where so that the internal energy of the gas increase and volumes increase with the temperature remaining constant. Question number is here. At 4 degrees temperature, the density of the water is found to maximum. Prove that the heat capacity of the constant pressure Cp, so constant pressures, so not critical temperature pressure, is equals to heat capacity at the constant volume Cv for a water at 4 degrees Celsius. Question number 6. Define a plane electromagnetic wave. A plane polarized wave is incident on a interference between two dielectric media. Obtain the expression for the amplitude of the reflected and transmitted waves when the incident wave is polarized with its electric field E vector perpendicular to the plane of incident. Discuss the phase relations of the reflected and transmitted wave with respect to the incident wave. Question will be here. What are the limitations of Rayleigh-Jeans law in explaining the spectrums of radiation forms a black body? Explain how these limitations were overcome in a Planck radiation laws. Question number 2. Deduce wind displacement law from Planck radiation law. And question number 6 is here. Write down Maxwell equation in the integral form. Explain the significance of each of these equations. Question number 2. A parallel plate capacitor has plate area 4.0 cm square and plate separation 2.0 mm and AC voltage V is equals to 20 sine 5 into 10 power t volt is applied across the plate. If the dielectric constant of the mediums between the plate is ER is equal to 2.0, calculate the displacement current. Question number 7. If the temperature variation of the heat capacity is known, how do you calculate the change of entropy during a isochoric process? According to Debye theory of a specific heats of the solid, the molar heat capacity of a diamond crystal at constant volume vary with temperature T as follow. So Cv is equal to 12 by 5 pi power 4 RT theta Q. This is Debye TQ device. So where R is the molar gas constant 8.35 into joule. So you read this. So and calculate the charge of entropy in a diamond of 0.3 grams mass when it is heat at constant volume from 0 kelvins to 300 kelvins. And question number B is here. The pressures on 100 grams of the solid copper is increased quintily, statically, and isothermally at 0 degree coulombs from 0 to 0.5 into 10 to the power 8 Pascal, assuming the density and isothermal compressibility to remain at a constant value of 8.96 grams centimeter cube and 7.16 into 10 to the power minus 12 Pascal respectively. Calculate the work done. Comment on the size and magnitude of the work. So comment out. Question number C. A system having two energy level minus 1 by 2 delta and plus 1 by 2 delta with delta is equal to 10 mega electron volt is populated by 1000 particles at a low temperature close to 100 Kelvin. Obtain the average energy per particle using classical distribution law. And question number 8 is here. A 0.5 meter long cylindrical medium between two conducting plates has uniform charge density of 100 nanocoulomb cube. The axis of the cylindrical medium is along z-axis. The left plate is at z is equal to 0 and has a potential of 100 kV and the right plate is grounded. Determine the electric field at the axial distance z is equal to 0.2 meters. And question number B is here. A uniformly magnetic sphere of radius r has a magnetization m is equal to m0z. If the scalar magnetic potentials inside and outside a sphere are given as under. So phi m is equal to m0 upon 3 m0 by 3 z r is less than capital R and this. So where r and theta are two spherical coordinates, find the magnetic field inside and outside the spheres. And question number C. Systematically show that the variations of the density of a state d and distribution function epsilon t of a particles in a non-relativity Fermi gas high temperatures. So at a temperature T, an electron occupy in a state with energy 100 mega electron volt above the Fermi energy EF with the probability of 100%. Find the temperature T. So question will be end. So that is all related to this discussion. It for today. Thank you very much.